In today's video, we're going to be talking about charge interaction. And after today's video, you should be able to determine the type of charge interaction between objects, understand the difference between, say, a conductor and an insulator, and understand what polarization is. So let's get right into the fun. There's a couple rules in terms of charge interaction, right? And the first rule is that opposites attract and likes repel. And I think this is a rule you guys have probably heard of before, but basically when we're talking about the subatomic particles of an atom, a proton, which has a positive charge, is attracted to an electron, which has a negative charge. Okay, and same situation here, here's a negative electron, it is attracted to this positive proton. Whereas down here, we have two protons, both positively charged, and they repel each other. They don't like each other. And the same is true with two electrons. Here's a negative electron, here's a negative electron. They're going to repel each other. Okay, so opposites attract, likes repel. Rule number 2 is that in static electricity, and when we get into current electricity, electrons do the moving, protons do not. Okay, and if you remember, protons are big. Okay, and I like to think of them as big and lazy. I think of a guy on a Saturday afternoon watching football on the couch with a bag of potato chips. That's in my mind what I see a proton doing. An electron, this is like a marathon runner. Okay, he's little, he's fast, and he does the moving. Okay, so electrons move, protons do not. Okay, that's rule number 2. When we talk about charge interaction between objects, you may be asking yourself, well, what about a neutral object? An object that has an equal number of protons and electrons. If it's neutral, what type of interaction does it have with charged objects? And the answer may kind of surprise you. A neutral object will actually be attracted to a positively or negatively charged object. Okay, so neutral is exactly that basically it will go towards the positively charged object, it'll go towards the negatively charged object. Now if you bring two neutral objects together, nothing's going to happen. But if you have a positive or negatively charged object, you will have some attraction there. Okay, conductors are basically any material that permits electrons to flow freely from particle to particle. Okay, and a good example of a conductor would be if you were to say put a hole in your wall and look at the wires in your wiring in your house. Those wires are probably made of copper, and so copper is a good conductor of electrons. In this picture, what's going on here is basically this is probably like a plastic pipe, a PVC pipe or something like that has been charged, and you can see it has a bunch of negative electrons on it, and this plastic pipe touches this metal ball. Okay, this is a metal ball, and it touched it right here, and it deposited a bunch of electrons. Because metal is a good conductor, the electrons are going to disperse all over the ball. Okay, and you can see here the electrons have distributed them throughout the sphere. Okay, and that's a real good example of a conductor. Okay, it allows those electrons to flow easily. The opposite of a conductor is an insulator. And an insulator is a material that impedes the flow of electrons from atom to atom and molecule to molecule. Okay, so a real good example of an insulator would be something like styrofoam or plastic. Okay, and again, if you feel like being really ambitious and putting a hole in your wall and checking out your electrical wires, those wires, the copper part of them, are probably insulated with a plastic coating. Okay, so you could actually, I won't recommend doing this, but you could actually go and touch the wire, and you shouldn't be electrocuted because there's an insulator separating the copper from your hand. Okay. So if a charge is transferred to an insulator at a given location, the excess charge will remain at that initial location of charging. Okay? And that sounds kind of confusing, but if, let's say I have a balloon, which balloons are kind of like a rubber. If I say charge up a balloon and I put a bunch of negative electrons right here on the balloon, they will not move. Okay, they will not go over onto this side, basically because rubber is an insulator and it doesn't allow for those charges to disperse or move. So here are some examples of insulators and conductors, and as we move from the left to the right, you get increasing conducting ability. So one of the best insulators that we can get is rubber, and then you have glass, wood. Air is actually a very good insulator, dry air that is. Then you have silicon, germanium, and all the way over to copper and silver. And you may ask yourself, well, why don't they wire houses with silver? Well, maybe you don't ask yourself that, because the answer might be kind of obvious. Silver obviously is very expensive, and so it's not economically feasible to wire houses with silver wiring. That would be cool, but typically we do it with copper because it's much more price friendly, if you will. All right, so what the heck is polarization? Polarization is basically the process of separating charges within an object. Okay, the positive charge becomes separated from the negative charge, and that's called polarization. All right, so I've got some pictures to show, or draw, I guess, here. Let's say we have a metal ball here on a stand. Okay, and I'll make the ball complete. Okay, so this stand is an insulator. Okay, and this ball is neutral right now. Okay, it has an equal number of protons and electrons. Let's say I bring a plastic rod near the ball, but I don't actually touch it. Okay, and I bring this negative rod, I'm going to call this negative, close to this metal sphere. Okay, and maybe I'll write that down, that this is a metal sphere. So it is a conductor. Okay. As these negatively charged particles come near the sphere, what's going to end up happening is the electrons are going to run away. Okay, because remember, they don't like these electrons here, right? They don't want to be close to them. So the electrons start to move over to this side of the ball, and what's left on this side is primarily protons. Okay, so let's see here, I have 3, 5, 4, 5. Okay, so the protons are over here on the left, the electrons have left, they're on the right, and this is called polarization. All right, this is called polarization. Basically, the ball is still overall neutral. Okay, there's an equal number of protons and electrons, but basically the left side of the sphere is positively charged, and the right side of the sphere is negatively charged, even though the whole sphere itself is actually neutral. Okay, there has been no charge transferred to the ball. It's just basically a separation of charge. Okay. Insulators are actually also able to polarize, but maybe not quite in the same way that a conductor can, because basically, remember, conductors allow the electrons to flow easily. What ends up happening is basically in each atom, so this is supposed to be a piece of wood, okay, which again is an insulator, and this is a balloon. If I bring a negatively charged balloon near this wood, the atoms in the wood actually have the electron kind of, if you will, lean away from the electrons in the balloon because they don't want to be near them. Okay, they aren't actually moving per se, but they lean away, so there is an overall positive charge on the left side of the wood, which allows a balloon to like stick to, say, a wood door. I don't know if you guys have ever done that in the wintertime, where you rub a balloon on your hair and then you stick it to like a wall or something that's an insulator. Basically, what ends up happening is that the charge, or the electrons, I should say, kind of just lean away, if you will, from this balloon. It's not that they actually move, because they can't in an insulator very well, but they try to get as far away as they physically possibly can from those electrons, and it causes the insulator to become polarized. So that is kind of the difference between a conductor and an insulator. A conductor, the electrons are able to actually like completely get away. In an insulator, they just kind of try to like, lean away from this charged balloon. Few warnings about polarization. I mentioned it 2 slides ago. Polarization is not charging an object. Okay, there is no transfer of charge in polarization. The particles in the object have just simply moved. Okay, they've rearranged themselves in some way, shape, or form. The net charge, though, on the object is still 0. Okay, and if I go back to this previous picture, these electrons on this balloon have not jumped off onto the wall yet. Okay, and they won't. Basically, this is just a movement of electrons, and the overall charge of this wood is still neutral. Okay, it has an equal number of protons and electrons. Okay, so that is a big warning about polarization. Sometimes students want to think it's actually charging an object. It's not. You're not actually charging the object. Okay, that takes care of today's video. I will see you guys next time.